Hello students, now let us continue with application 3 of Gauss theorem, wherein we are supposed to find out the value of electric field intensity due to charged body of any shape at any point just outside it, right? So students, in this particular module, we'll be dealing with the mathematical part of this particular application, right? Now, before starting with the mathematical part, let us see what we have learned up till now. In the previous module, we have taken a charged body of any shape. Now, see the shape of body, it is irregular. And as the shape of body is irregular, the distribution of charge is non-uniform in this case. And as distribution is non-uniform, surface charge density, that is sigma, is given by dq upon ds, where dq is the small charge and ds is the elemental area, right? Now we are supposed to find out intensity at point P, right? So we have considered point P, which is just outside. Now in order to find intensity at point P, we have considered a small elemental area on the surface of this body. Now see, elemental area ds is there, and we have considered one more point, that is point Q, which is just inside the charged body, and we have constructed an imaginary cylinder with PQ as a natural axis and ds as the cross-sectional area, and this particular cylinder is enclosing small elemental area ds, and on that small elemental area ds there is small elemental charge dq, and as this cylinder is enclosing small elemental charge dq, we have called this particular cylinder as Gaussian cylinder, right? Now then after this we have found out the value of enclosed charge. So the value of enclosed charge, it is equal to dq, and the value of dq is nothing but sigma ds, right? Now let us move further and let us calculate T and EI, that is total normal electric induction. Now firstly we will be calculating T and EI by Gauss theorem, and according to Gauss theorem, total normal electric induction, it is equal to enclosed charge, right? So what is the value of enclosed charge? See, the enclosed charge, it is equal to sigma ds. So therefore T and EI, it is equal to dq and it is equal to sigma ds, and we have called this as equation number 1, right? Now let us move further. Right, now let us calculate T and EI by general method. Now students, see the diagram carefully. We have to find out T and EI for the cylinder, right? So therefore T and EI for the cylinder, it is equal to, now see the diagram carefully. A part of cylinder is outside the charge body and a part of cylinder is inside the charge body. So therefore T and EI of cylinder, it is equal to T and EI for the outer part, now see the diagram, plus T and EI for the inner part. Now see the diagram carefully, right? So T and EI of cylinder, it is equal to T and EI for the outer part plus T and EI for the inner part. Now student, charges are present on the outer surface of the body. There is no charge present on the inner surface of the body, or there is no charge inside the body. And as there is no charge inside the body, T and EI for the inner part, it is equal to 0, right? So therefore T and EI of cylinder becomes T and EI for the outer part plus 0, right? Now let's move further, right? So this is what we have got, T and EI for the cylinder, it is equal to T and EI for the outer part plus T and EI plus 0, right? Now students, see the outer surface or the outer part of the cylinder carefully. Again, it is having two surfaces. One, it is having curved surface and the other surface is plane surface. So this T and EI for the outer part can be written as T and EI of curved surface plus T and EI for the plane surface, right? Now let's move further. Now students, since we have enclosed elemental area ds, we'll be writing the value of T and EI as epsilon E cos theta ds. Will not consider integration sign. And why we are not considering integration sign? Because we have enclosed elemental area ds, right? So therefore T and EI of cylinder becomes T and epsilon E cos theta ds for the curved surface plus epsilon E cos theta ds for the plane surface, right? Now let us move further. Now let us discuss about theta. What is theta? Theta is angle between vector E and vector ds. And what is vector ds? It is nothing but the area vector. Now students, for positive charge, intensity is always directed away from the charge and it is always perpendicular to the surface, right? So let's say I'm having intensity. Now see elemental area ds, it is having positive charge. So for this elemental area ds, intensity will be directed away from it, right? And it will be perpendicular to area ds. Now see diagram carefully, that is nothing but the direction of intensity, right? Now let us draw an area vector for the curved surface. So for curved surface, now see the diagram carefully. I am drawing an area vector. So this is area vector ds. Now what is angle between vector E and vector ds? See carefully. Yes, it is 90 degree. So angle between vector E and vector ds for the curved surface, it is equal to 90. So therefore I can write theta is equal to 90. Now let us draw area vector for the plane surface. Now let us see the diagram carefully. So we have drawn area vector ds for the plane surface. Now what is angle between vector E and vector ds? In this situation, angle between vector E and vector ds, it is equal to 0, right? So for curved surface, theta is 90. For plane surface, theta is equal to 0. Now let's put, we know value of cos 90, we know value of cos 0. So we know that cos 0, it is equal to 1, and the value of cos 90, it is equal to 0. Now let's move further and let's put the value. So we'll put theta equal to 90 in curved surface, right? So this particular term will become 0, right? Because cos 90 is 0, right? So therefore Tn EI of cylinder becomes 0 plus epsilon E cos theta ds for the plane surface, right? Now let's put theta equal to 0 in case of plane surface, right? So what is cos 0? Cos 0 is 1. So this particular term will become epsilon E into 1 into ds. So therefore Tn EI of cylinder, it is equal to epsilon E into 1 into ds, which is nothing but equal to epsilon E into ds, and let this be my equation number 2, right? Now let us move further. Now let us equate equation 1 and 2. So what we'll get? We'll get sigma ds, it is equal to epsilon E into ds. So we can cancel out ds, right? So after cancelling out ds, we'll rearrange and we'll get the value of E. So therefore E is nothing but equal to sigma upon epsilon. And students, this is nothing but the expression for electric field intensity due to charge body of any shape at a point which is just outside it, right? So students, so in this particular module, we have dealt with the mathematical part of application 3, and we have derived an expression for electric field intensity. So students, that's it for this particular module. See you in the next module. Till then, keep learning.